Alright, so today we're going to talk about the trig functions, do a light introduction. Nothing super in depth, just talk about what the trig functions are, how do you use them, how do you type in your calculator, why would we want to learn this. So we're going to learn some new buttons on your calculator. So if you have a calculator, you want that out, make sure that it does have the scientific keys on it. Not just the square root button, but you need the other buttons as well that, some of the other ones that you probably don't recognize yet. So that's what we're going to talk about today. Now, before we get to that, the stuff that's in your homework that I have written over there that's due Monday, that's the page 551 stuff. Okay, so due Monday, make sure that you're taking your time, you're doing those calculations. I think it's pretty easy. Most people are already turning it in. I know those first few problems, they're just having you do Pythagorean theorem. They have one wall missing out of three. One wall's missing, and you can do the Pythagorean theorem and find it. That's the type of problem that you had in your homework. Again, how you do the Pythagorean theorem on this problem, you square the two smaller walls, if it's a right triangle. You square the two smaller walls, you add those together, and you set it equal to the bigger wall squared. And then you just solve. It could be a decimal, it could be a whole number, whatever. But that's what you did in your homework. I think we've done that the last 3 days. You should probably be pretty good at it by now. Those are easy. Now, the second type of problem, I think it was like 6 through 8, and it was the 21 through 23. Those problems were a little bit different. They did something like this to you. They gave you three numbers, and they simply asked, number one, are the following numbers representing a triangle? That's the first question. Is that a triangle? Yes. Number two, what classification? Is it acute, right, or obtuse? If it's a triangle in the first place. So that's a very big if. So here's what you do if you have this type of problem, because I want to give you an example, because I had a lot of questions on this today. You need to draw a mock picture of your triangle. Now I know I'm drawing a right triangle looking thing. I don't know if it is. That's what we'll figure out. So this is 7, this is 14, and this is 23. Why did I put the 23 there?
It's the hypotenuse.
Yeah, it would have to be the biggest wall. In theory, it's the hypotenuse wall. He's absolutely right. If it's a right triangle, that's the hypotenuse. It had to be the biggest wall. Now, the simple check you have to start with first. First step. Is it a triangle? You have to actually check that. I know that seems stupid. You do have to see, is it a triangle in the first place? Because if it's not, you're wasting your time. Okay, so here's how you check. Pick any two walls. So I'm going to pick the 7 and 14. Okay? Whatever two walls you pick. You add those together immediately. Don't even square them. I'm not doing the Pythagorean theorem or anything. You add the two smaller walls. This number, what you get, has to be larger than the third wall. Has to be. If it's not a triangle. So what's 7 plus 14?
21.
21. We have a problem.
What if you picked the other two walls?
It doesn't matter. You have to pick any two in such a way that if you can find that one of the pairs is not going to add up to be more than the third wall that you picked, so I always just pick the smaller two, that's how you guarantee it. If it's not bigger than the third wall, this is not a triangle. So in fact, this is not a triangle. And you wasted your time, moved on to the next problem. Because it can't work. Now, a lot of people always ask, like, Ward, how do you know that? Walking around the block, like in terms of distance, should always be longer than somebody taking the shortcut home. This should be the shorter distance than somebody going around the block. That's why it's not a triangle. In fact, probably the more accurate drawing would be something like this. This would be probably the more accurate drawing, where there is a gap here. It's not even touching. And it won't, because it's not a triangle. So that's the accurate drawing. Now, to make it an actual triangle, let's say I shorten it up a little bit. Let's say we go with instead of going 23, let's go 20. Not 21.
If it's the same.
If it's the same, it's still not a triangle. Has to always add up to be more. Can't be equal. So let's say it's 20, not 21. Because if it's 21, it's not a triangle. It has to be bigger. So we're going to do this. So this is 20 now. So you add these up. 7 plus 14. Yeah, that makes 21. And the other side was 20. So yeah, it is bigger than the other wall. So yes, this is a triangle. Now we have to figure out what type. That's where you square these. So 7 squared plus 14 squared, and we have to see how does that relate to the 20 squared. So 7 squared is 49. We're going to add that to the 196, and we're going to check that with 400. If I add these together, I get a 245. Okay. and this is 400. So you see that the hypotenuse is way too big. Right, the hypotenuse is way larger than the other two added together. So this is actually an obtuse triangle. It's obtuse. The hypotenuse is too big, so it's obtuse. If the hypotenuse is too small, it's acute. And if it's perfectly equal when you do the Pythagorean theorem, then it's a right triangle. Any questions with how to do those 6 through 8 or 21 through 28? Now you all have decimals, you can just type those in. Okay, we good though? Just a lot of people needed to see that, they just didn't know. I had a lot of questions on that this morning. Okay, let's go on. Let's actually talk about our trig function today. I want to talk about just one trig function. I don't have you very long today, so I just want to talk about one of them, do an example, and then we're done. So it's pretty straightforward. All right. Get to that. Let's get rid of this. Okay, now remember your next period is period 4. So just kind of keep that in mind. I don't know what time we're at here. What time are we at here? We're out of here at 1 o'clock. So we got about 20 minutes. Okay. So I'd like you to write this down. This is our acronym we're going to be using today, which you saw on the board when you first walked in. Sohcahtoa. It's just an acronym. Sohcahtoa. So it's S, C, and T. Those are all capital letters. Then we have an OH, AH, and an OA. And those are lowercase. I try to make the A's and O's clear, but if you can't see it. We're just going to talk about the first one. What this little acronym is, it's a little acronym that helps us remember the formulas for these trig functions. Now what trig functions are? They are functions that are built into your calculator, okay, that will help you find the lengths of walls or angles in a right triangle. They only work on right triangles, that's why it's in chapter 8. But it's really easy. They're pre-programmed in your calculator to help you find angles or walls, depending on what you need. That's why it's kind of brilliant. So if you're looking at your calculator, so if you have that out in front of you, you'll probably notice there's an SIN button, a COS button, and a TAN button, tan. So sin, cos, and tan. Okay? Those buttons are the trig functions. They're basically used to help you find walls or angles, depending on how you type it and what you do. So the goal is for today and tomorrow, well today we're going to intro how to use this, but Monday we're really going to jump feet first into this thing, and we're going to really figure out like how do you do it, how do you find angles, how do you find walls, how do you do it in every situation. So we'll really kind of go through this. Now what we're actually doing here is we're doing trigonometry. Now if you don't know what trigonometry stands for, it's the study of triangles, but we're mostly just focusing on only right triangles. So it's only right triangles that these work. Eventually, if you get to Algebra 2 or pre-calculus, or calc, we'll eventually show you ways to cheat this, so you can apply these to non-right triangles, which they call oblique triangles. But for right now, they only work on right triangles, unless you know your little cheats for how to do it. But the goal today is figure out the formula, and then figure out how do you type it in your calculator, because it is super easy. It's pre-built in your calculator, so that you can just type it in really quick, and boom, it spits out an answer. It's actually, I'm not even joking, I think this is honestly easier than doing the Pythagorean theorem. It's a very short formula. You need 3 numbers. Done. Boom. Plug it in. Calculator spits out an answer. Super easy. Okay. All right. So let's do the first one today. We're going to deal with this one. That's the only one we're going to look at today. It's called the sine function. That's what the S stands for. The sine function. Okay. Now what this is, it's a relationship of certain angles to certain walls in a right triangle. So if you had a right triangle, so let me draw one here. Has to be a right triangle, so I have to have a right angle in there. There's a certain relationship of walls to angles here. I don't need 2 walls to find the third wall anymore, right? I don't need to use Pythagorean theorem. I can use this function on my calculator if I have other parts other than just 2 walls given to me. I could use this if I have 2 walls, but it's used for other purposes. So here's your formula. I'm going to write it down. So SIN, so sin, or sine, that's how you pronounce it, sine, of an angle. So when you type that little button on your calculator, it's waiting for you to type an angle after it.
So
that's why I'm like the most, SIN button. So when you hit that button on your calculator, it usually puts a parenthesis after it, because it's waiting for an angle, for you to type in an angle after it. Okay? And now what that does, if you actually type an angle and hit enter, it gives you a weird, crazy decimal across your screen. Because what it's actually doing, is it's taking 2 walls of your triangle, and dividing it. That's what it's doing. So here's what it's doing. So if you typed in sine of an angle, which I'll type in here in a minute.
Got a straight one.
Okay, yeah. So you probably typed in what, 90 or something like that? Yeah. So, all right, I'll talk about that. All right. So sine of an angle. Now what this stands for? The O and H. The O goes on the top of your fraction. So the O goes on the top of the fraction, and the H goes on the bottom. That's how all three of these are going to work. The second letter will always go on the top of a fraction. The third letter always goes on the bottom. Now, what these letters stand for? O stands for opposite side. I'll explain that word here in a second, like what is opposite side, like what are they talking about? I'll talk about it here in a second. And then the H stands for the hypotenuse, which is a word that you guys should be very, very familiar with on a right triangle. Okay, so opposite side and hypotenuse. That's what the formula is. But again, this little acronym tells me sine of an angle is opposite over hypotenuse. That's how I always remember it. That's the little acronym. And this acronym is found in every textbook. It's everywhere. Okay? All right, but let's type in a number. So I need an angle, please, other than 90. It has to be less than 90.
75.
75. I like 75. All right, let's go with that. 75 degrees. And I could put that angle anywhere I wanted. I could put it up there or down here. It doesn't matter. Let's say it's right here. Okay? So from this spot, the 75 that you picked, this wall that's across the picture, that's the opposite wall. The opposite wall is across from where your angle's at. So now, if you picked the angle up top, the opposite side is the one on the bottom. You go straight across from it. So we're going to be using the opposite side, the opposite wall. And where does the hypotenuse need to go on this picture? Yeah, the big wall, right? The hypotenuse never changes. The hypotenuse is always the same wall every single time. You should know how to find the hypotenuse. It's the biggest wall, or it's the only wall that doesn't touch 90 if you want to think of it that way. So the hypotenuse should be like really the first wall you always label, because it never changes. But the opposite wall could, because depending where your angle sits. And we never use the 90 degree. We always use the other two, the smaller ones. We always use acute angles, something smaller than 90. All right. So what we're going to do here. Let's say we know the hypotenuse. So someone give me the hypotenuse number. Any number
84.
you want. Say it again.
84.
84. You want feet, meters, yards, centimeters? What do you want? Miles?
Miles.
Miles? Okay.
Kilometers.
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 Right. Kilometers. All right, so 84 kilometers. Okay. So that's a very, very long distance. The idea is maybe for some reason you're using a rangefinder, right? So rangefinder is a little tool it uses radar and stuff. You point it at an airplane. You should never do that, by the way. But you point at an airplane to see, how far the airplane is away from you. That's what a rangefinder does. Okay, it's illegal. Don't do that. So you look at the little rangefinder and it says, oh, the airplane is 84 kilometers from you. That's a very long way, by the way. So 84 kilometers away from you. What this formula can do, it can figure out the opposite wall. Like, what the opposite wall is? How high the airplane is in the air. That's what it's going to tell you. That's what this formula can do for you. By just knowing 2 out of the 3 numbers on this formula. So I'm going to find how high the airplane's up off the ground. So here's my little airplane. Okay, make sense? All right, so looks more like a duck, but anyways. So we're going to find the opposite wall. So how these work? You plug the numbers where they need to go. So sine, what was the angle we picked? We picked 75. Is the opposite wall. The opposite wall is the one wall I don't know, so that's my x. That's the wall. We're trying to find how high the airplane is off the ground, the altitude of it. That's the word. And then the linear distance to the actual plane itself is 84 kilometers. So somehow we knew that. I don't know, a rangefinder, or maybe it's a hot air balloon, there's a rope attached to it, you know how long the rope is, I don't know. Something like that. Or maybe it's a ladder leaning up against something, you know how big the ladder is. Now a lot of people always say, Warren, how do you know the 75 degrees? Like, that one makes sense, you have a rangefinder or you know the ladder leaning up, but how do you know the 75? There's actual technology you can use here. Everyone's got a smartphone, correct?
Yeah.
Everyone's got one. I have an iPhone here, so, alright, so here's how this works. On an iPhone, there is the compass app. Everyone knows it, everyone probably just deletes it immediately because no one ever uses
So there's
it.
a level
Okay.
you swipe.
Yeah, and this is a lot of things, like when you first open up the compass app, you have to do that little thing where you wrap it around until it points to north. But what a lot of people don't know is, like what Kevin's saying, if you swipe to the right, it gives you a level. Now, the level tells you what angle you're tilting your phone at. This is how you would actually like set like a picture on the wall so it's level. Okay, you just put this on top of the picture and then nail it in, right? But what you can do is you can tap the screen and it puts it back to 0. Okay, so what that means is you can set your phone on the ground up in front of Vanessa here. Vanessa, tap the screen, so it goes back to 0, tap it again. Okay, boom, 0. Now, Vanessa, tilt the phone. Just tilt it, just pick it up. Boom. What angle does it say on the screen?
72.
72. It tells her the angle she's tilting the phone, any direction you want to go, front, side, whatever. So what you can do is if you had, let's say, a ladder laying up against a building, you put this on the ground, you tap it so it levels to the ground that you're on, and then you just set your phone on the ladder. Let's just put it right on the ladder itself, the rung of the ladder, and boom, it tells you it's a 40-degree angle, or in this case, 75, right? So that's how you can do it. Now, why that's important, now you can figure out how tall the object is. Because you have the angle. By using a simple technology, it took me 1 second to do that. I know maybe the ladder, or in this case, I have a rangefinder to get to something. And now I can figure out how high it is in the air. Because all I have to do is hit X by itself and type this in the calculator. And it takes 1 second. In fact, they have these buttons on your iPhone. Just turn the phone sideways and they show up. Okay? So, how do you solve this? If they're taking X divided by 84, what is the opposite of dividing by 84?
Times you by it.
Yeah, you multiply by it, right? So you multiply by 84. So it's 84 times the sine of 75 degrees. And when you type that in your calculator, it spits out how high it is off the ground. In this case, or how tall the object is. Okay, now, for everyone in this room, I think you can just type it exactly how you see it. 84 times sine of 75, you hit enter. But, here's the thing, everyone turn on your calculator, right? Before we start typing this in, somewhere on your screen, does it have a DEG or a little capital D somewhere in the corner? Is that somewhere on the screen? DEG or a capital D? DEG, okay?
I have ENG.
What?
ENG.
Okay, we gotta get rid of that.
Yeah,
And
you put it on
RAD.
mine too.
Yeah, you don't want that. So, you definitely don't want that. So let's reset that.
Is that why it gives me a
Yeah, mine
negative?
says
Yeah,
ENG.
it's giving you wrong answers. So, oh yeah, so you guys are on the wrong ones.
How do you reset that?
And RA.
You have to hit the reset. It's like shift 0 and you reset. Okay, DG. Anyone else have like weird things?
I have a D.
Okay, a D, that's fine, that's what you want. Because it's certain calculators, they just put a D on the screen, so DEG. Okay, boom, you're back to DEG mode. Alright, anyone else need me to like fix yours? I think yours is a D. Okay. It doesn't have an RAD, or an ENG, or an FIX, or a GRAD graph. Okay, it has to say DEG, because you have to be in degree mode. We're typing in degrees here. Because when you type it in, it automatically knows it has to be in degrees. That's why it has to be in DEG mode. Okay, type it in, what do we get?
81.
81, even?
0.13.
0.1, alright, so 0.13, and this is in kilometers. So, that airplane, that object is 81 kilometers off the ground, if that's the right number.
What do the other ones mean, like radical, rate?
Radians, which is a different type of angle, it's kind of like degrees to, it's like feet to centimeters, right? There's a conversion there. And then gradient is a type of leveling that they use in like engineering. So they're just different forms, they're just different labels. But for our purposes, since we're using degrees, we have to put it in DEG mode, or D mode, wherever it is for most calculators. Now, for yours, I think you have to type it in backwards. So, because you don't have a menu driven, so you have to type in the 75 first, type sine, and then take it times 84.
No.
Okay, because you have to type it backwards, because you can't see it all on the screen before you hit enter. It does like everything as you type it, so you have to be kind of careful on yours. I think everyone else has a calculator like mine, correct? You can just type it in exactly how you see it and then enter, and it works, so that's kind of nice. Not bad, you just type it in backwards, so it's
How do
fine.
you put it in normal mode?
Normal, I wouldn't do that. So that just gets rid of decimals and stuff, I don't want to do that. All right, questions on how to type that in? Are we comfortable with that? Now, as you can see, like, this is super, like, easy to calculate as long as you have two numbers. I don't need to find the third wall. I don't need to do Pythagorean theorem. I can just have an angle and a wall, and boom, I can find everything else about the triangle. And what we're gonna learn on Monday is the other two. Now this one, I'd say this is probably more practical if you wanted to find, let's say, a height of an object or the ladder that you need to lean up against something. That's probably more practical for these. This one is probably the more familiar for everyday use, would be this one. And that's the one we'll really focus on Mondays. Like, this is the one that we use probably more often than the other two. But you can already see, like, there is a purpose to it. I know it's a little far-fetched, the story I came up with, because I was trying to adapt it to your numbers, but you can use it, and it's easy. Every calculator has it as long as it's scientific. Even your cell phones have it. If you turn the cell phone sideways, it shows the buttons. So you just have to do it like that. Maybe that's something you want to figure out on your phone. How do you type it in correctly? Because like Laura had to type it in backwards. Maybe that's the way you have to do it on your cell phone too. Just type it in backwards because she can't see everything typed on the screen before she hit enter. Okay? So try to figure that out and see if you can use it. All right, calculators, if you borrowed from me, make sure you get them back, but we're done for the day. Very nice, very easy.